Hi everyone, thanks for joining us for this session today. I'm your host, Mala Gupta. Today I'm pleased to welcome Elder Moraes, Java champion, published author, and developer advocate with JetBrains. Today he'll present on a very relevant topic, Java and containers. Hi Elder, it's a pleasure to have you present today.
Hi, Mom. Thank you very much for the invite and thank you for having me. I'm very happy to be with you today.
Thank you. And before I let Elder take the stage, let me share some quick housekeeping details. Everyone who's attending the session today, please use the YouTube chat to post your questions. I, Serki, and Michael from the JetBrains team will answer your questions as you post them. And Elder would take your questions towards the end of the session. And the session will be recorded and hosted to IntelliJ Idea's YouTube channel. So if you haven't already subscribed to it, please do so that you know when it's live. So Elder, now I'll let you take the stage now.
Okay, thank you very much again, Mala. And especially thank you that is watching us today here. This is my last session of this year, so I'm very happy to be with such a good audience and great audience at JetBrains. And thank you again, Mala, and all the team for the invite. So I believe that you are able to see my slides already. So let's talk about Java containers and how I work with Java containers using IntelliJ. Okay, so when I first heard about containers back in 2014, maybe 15, and I watched my first sessions about it and read my first articles about it, my picture of how would be to run Java and containers was something like this. Okay, so everything just working, everything just well organized and being well orchestrated. But on my first experience using Java and containers was really something like this. Not so well organized, not so well orchestrated, and well, not working as I was hoping that it would work. So I realized that we really needed some more knowledge, some more expertise on using Java and containers because Java has some specific um, features and behaviors, especially on this kind of environment called containers. That's why I created this talk and I will share with you guys here today. Before I keep going, just to quickly introduce myself, my name is Elder Moraes, as Mala said. I'm a Java champion and I work at RedHat as a developer advocate. Here you will see the QR code and the URL for my mailing list. So if you would like that I share with you my latest insights about Java, containers, microservices, cloud native content, you can always subscribe to this mailing list and I will share with you. I'm also a board member at SouJava, one of the biggest Java user groups in the world. As Ma also said, I published the second edition of my book, the Jakarta EE Cookbook, and my mission as a professional as a developer advocate is to help Java developers to build and deliver awesome applications so they can work on great projects. All right, so our conversation here today will approach to four main topics. The first one is four main issues when using Java and containers. So the first one is the long build time when we are building container images. The second one is huge image size, especially, of course, when working with Java. The third is the value maintainability and how we avoid it. And the last part is resource allocation. Okay, and please, you don't need to mind of taking pictures or getting notes, taking notes, because I will share all the code that I will share with you here today. It's already available on my GitHub repository. Okay, so you can go there, and this presentation will also be available to you. So don't worry, just listen and follow me and enjoy. Okay. All right, so of course I will show you a lot of code today. So let's jump to the IntelliJ. Let me just check my screen here. Okay, so everything looks fine. Okay, so the first part of this presentation is about build time. Okay, because when we are working not only with containers, but especially the containers, our subject today, you will not build one container image. You build probably dozens, sometimes hundreds, sometimes even thousands of containers image. And now those images probably being built on some CI/CD. And if you take too long in all of them, your CI/CD will take too long to make all the cycles. So whatever you are able to reduce the time that you take to build one single image, it will improve your whole life cycle. So that's why I created this part of the presentation. Okay, so here, this is our first Dockerfile. So it's a usual Dockerfile. Okay, so a from, I will use a Debian here as our reference. And I will copy the libraries and the jars of our application, and we'll run apt-get update, apt-get install, and install some stuff. And then in the end, it's our CMD of a Dockerfile. This is our first don't. Okay, so don't do this. Okay, I'm showing you, but don't do this, and I'm sure why. So let's build this image, and let's see what's going to happen. Okay, so let me go here. I will just check if I don't have any of my tests still available. I don't believe so, so let's just make sure. Docker image, okay, here's my reference. Okay, so let's just build this image. So right now it's copying the libraries, then copying the file of the application, and now it will starting running the apt update and then apt install. This process will take kind of 50 to 1 minute, 50 seconds to 1 minute. Okay, so depends of my network here, but on my test today in the morning, it took like 1 minute to download all the files for this process. Okay, and I know sometimes it's boring on presentations like this to see things being downloaded. But as I'm talking about build time and to reduce build time, it will make a lot of sense in just a few seconds why I'm doing this. Okay, so please make yourself comfortable and wait just kind of 15 seconds or even less that this will be done in a bit. Okay, so the triggers are the part, and let's, okay, good, amazing. So this process took around 28, not, I don't believe it's 28, okay, but now it's telling here to 28 seconds, okay? So I have my image just built, okay? So if I go here to my Docker images, I have my new image here, okay? And if I just try to build again, it's almost instantaneously. Why? Because we have something called cache. If you look here on the second step, using cache. On the third step, using cache. On the fourth step, using cache. On the fifth, and on the sixth. Okay? So, because once you build a new image, your container engine will build a cache for each layer. Each line of your Dockerfile will create a new layer, and that layer will be cached. And in the next time when you do a new build of that image, if that layer haven't changed, it will just use the cache to build a new image. That's why when I try to run this command again, the image is basically the same because nothing changed. It just used the cache and good to go. Not even 1 second to build this image. right, good. Now let's try some stuff. Let's try here to package our application again. Okay, I didn't change anything, but once I package it again, this application will be like a brand new application to our cache on the process of building the image. Okay, so let's try to build this image again. I will stop because it will take like 1 minute again, but let's see some stuff here. Okay, so the first part, the libraries, it was able to use the cache because the library didn't change, but the application changed, so it wasn't able to use the cache, so it created a new layer again. But you can see here that it wasn't able also to use the cache of the whole part of the Dockerfile that's following this command. Why? Because once I broke the cache of one part of the Dockerfile, everything that is following these commands will also be broken. So I broke the cache of the whole Dockerfile just because I changed nothing on my application, just because I packaged my application again. How should I do? What should I do to avoid it? Okay, so let's check here. So I create a lot of don't and do here so you can check by yourself later. Oops. Okay, so this is what you really should do. So let me really build a new image here, and while it's building, I will explain it to you. So I will package the application again, just to make sure that we have a brand new application to be containerized. And let's clean here and build. And okay, so it will do all that it needs to do, and I will explain to you. So if whatever part that I break the cache on the Dockerfile, I will break the cache in the everything that is following that command. So what should I do? Should I put all the parts of my Dockerfile that change the most in the end of the Dockerfile, and all that parts that don't change or change less frequently, I will put in the beginning. So I just switched the order here. So I put the apt-get and update and install that will change or will change very rarely, and I will put my application in the end of this Dockerfile, because if I break this cache in the end of the file, it will make no difference, at least in this case. Okay, so, and I will show you the comparatives between both approaches. Okay, so it's processing the triggers, and okay, so now it took like maybe 30 seconds again. So let's, well, okay. If we just run again, it's instantaneously, of course, because I didn't change my application. But now let's change the application. Let's package the application again and see what happens. Because in the last example, once I packaged my application again, I took 30 seconds again to build the whole image. Okay, but right now, as I just switched the order of the comments, if I try to build this image again, boom, instantaneously again, and you can see here that we are using the cache of the library, but we are not using the cache of the jar. We still broke the cache, but I broke the cache in a part that makes no difference. So it's almost the same time. So the main concept that I would like that you keep on your mind on this part is that the order matters for caching. Okay, so once you are building your Dockerfile, you should pay attention in the order of you are putting all the commands, all the files, whatever you are doing, because the order matters. So put in the last part what changed most, and put in the first part what changed less. Okay, good. Let's go to the second example. So, okay, now we have a better way, and this better way can still be improved. Okay, so our better way is now our don't. So I will make this. This is this Dockerfile is exactly as the last one. I will just use it to build a new image so we can have all them being comparated. So I will build this guy here. Okay, it's instantaneously. And let's, how can we improve, still improve this guy here? So let's check here. Okay, what we are doing right now. Let me just open the last one. What's the problem here? Okay, if you look here in this copy comments, I'm using copy lib and star and okay. And for the libraries, it doesn't have many problem because library we will not change that much. But your runner, your jar file will change more frequently. Okay. And what I'm doing here, I'm using star to copy my jar file. And what's the problem? I will show you the problem. Let me just close here. I will package the application again just to make sure that it's still works. It's really a brand new application. Okay. And I will build the image. Okay, it's fast, and we are not using the. Let me. Okay, so we are not using the cache, of course, because I just package the application again. Let's try one little thing here. I will create my hand a file called, for example, JetBrains runner.jar. Okay, and I will.
Elder, I'll have to interrupt you for a moment. The
Sure.
voice, it's not so audible. So, is it possible for you to change the level of your microphone, or probably speak, I don't know, a bit with less? I don't know.
Uh, what about
Probably the
right now?
same.
It's better right now, or still?
Uh, Speak again so that I can
Okay,
check.
can you hear me better right now? It's better. The level is still. You
If
can't
you
hear
could
me
decrease
still.
that, if you could decrease that a
Decrease.
bit more. Yes.
Oh, decrease. Okay.
Yeah.
Okay, just a second.
Yes.
What about now? It's better.
No,
It's
no,
better.
it's getting no.
What?
I
Nope.
think you can go back to the no initial one. Now it's not audible.
What about now? It's better. Right.
No,
I'm
no,
sorry.
it's getting worse now.
Oh, I'm sorry. I'm sorry. I changed the wrong place. What about now? Can you hear me well?
N- No. Yes, now
What
it's
about
okay.
now? What about
Yes,
now?
yes, it's okay now. But if you
Better
could
now?
decrease, yes. But could you decrease the level? I think the same problem that I had before we started the session. So mine was too low. Yours seems to be a bit on a higher side. So if you could decrease the level a bit.
What about now? It's better
Perfect.
now.
Yes.
Perfect.
Yes. Yeah.
Yes. Okay.
Thank you so much.
No worries. Thank you, Mala. And sorry, sorry about it. Okay. Well, just to a quick recap here. So what I was showing you is that as I'm copying here using a star, okay, whatever I put on that folder, if I create another files by mistake, it will also broke our cache here. That's what I was just about to show you. So let me run this command here. And right now, if I go here to the copy, so you can see that I was not able to use the cache, even though I didn't change my application, I didn't package my application again. But there is a new file on the folder, so the engine recognize, well, the cache is broken, so I need to build another cache. So what I was supposed to do instead is to just go here and be specific. Okay, so instead of using star, you should copy the real file. Okay, so let's try this. Close this guy here. I will really package the application again. Let me copy this guy. All right, so we'll build a new image. Okay, as I build a brand new version of the application, I wasn't able to use the cache. Let's package the application again. Ah, sorry, my mistake. But just a second. Okay, right now, then now I need to break the cache. Okay, so I will use that touch to create a new file by mistake, and then I try to build the image again, and I was able to use the cache because this guy, because as I have been do it very specifically, so I didn't broke the cache. So whatever is possible, of course, on the libraries, maybe we have here 20, 30 libraries, I don't know. So it's more difficult, but if it's a production application, it's still worth it, because if you need to add one new jar file, so it makes sense to go to the Dockerfile and add that one new Dockerfile. Okay, so first part was to mind the order of the comments, and here is to be specific. Okay, this is the state of this file, but we are still able to improve it. Okay, so we are here we are mind the orders, and we have been very specific. So how do we improve it? So let me just create a new version of this container based on the last one. And how do we improve it? Okay, this is a very, very same, but I just create another one so we have the pairs being improved as we are going here. Okay, what I'm about to do here. If you take a look here, I was running before run apt-get and run apt-install. And here we are doing what we call a group unit. Whatever you can group on your Docker file, please do it. Please group it. Because once you are grouping whatever is possible to group, you are making the life of your caching easier. Okay, because this command here will create one single cache for this group unit, for all these commands that is being built here. Okay, so I will, let me make sure that I copy the right command. And okay, it will download a lot of stuff again, so I will, while it's being downloaded, I will share my slides again just to make a quick recap. So we are talking here about how to avoid long build time. And first is mind the order for caching. Okay, so avoid to put your application, whatever, change with a lot of frequency on the first, and instead do it on the last part of your Docker file. Whatever change the most, you put on the last part of your Docker file. The second concept that we talk here is being specific for caching. Okay, so instead of copying our files using stars or whatever other feature to do it, you should be specific. So copy the real file to that folder, so you will avoid to have any problems, even with copying the wrong files and also preserving your cache. And the last part was group units for caching. Okay, so instead of having a lot of run, or another command, if you can, please group them, because you will create a single cache for that part of your file. Okay, and let me check here. Oh, right on time. Okay, so now we have here, if I run again, this, you will see that we have one last step, because we were able to group it, this apt-get, update, install, and whatever. Okay, good. So this was our long build time process. Now let's talk a little about how do we decrease the size of our image. especially when we talk about Java, it's something to really take care about it. Let me just grab some water. Okay. Let me jump again to my IntelliJ. Here I will switch. Oops. Switch files here. Okay. Now let's talk about how can we do to decrease the size of our images. Okay, let me close this guy here and open this other guy here. Here is basically where we was on the last part, so we'll just copy the file. This image is basically the same. If you are paying attention, I got my first Dockerfile and I'm improving it until the end of the session. Okay, so we are building one concept in the top of the others. Okay, so I have here basically the same concept, but the same Dockerfile that we had in the last part. So how can we improve it? Let's do this. Here, I will run and then explain because I will take like 1 minute again. Okay. All right, so what I'm doing here, guys, two main concepts. First, this magic flag here, no install recommends, because the package manager, especially this one, the apt-get, once you are installing or updating whatever you have on your operating system, it will install automatically all the recommendations because you have some packages, some applications, whatever you are installing. Oh, there is this recommendation. If you don't use this flag, it will install all the recommendations by default. Okay, so I'm encouraging you here to use this flag to avoid to install automatically whatever you don't need to install. And also, I removed here the installation of SSH and VIM. And why? Because I ask you why you would need an SSH and a VIM inside a container. Oh, sometimes I need to debug, sometimes I need to do. Okay, so once you need, you go ahead and install. Don't let anything inside your container if you don't really need to use it. Okay, don't let anything inside your container because maybe sometime in the future you're gonna need it. No, please don't do it because you will keep your image bigger than it should be. Okay, so now our process is done here. Let's compare. So we are on the okay, size one. Image. Let's check our last image here. Okay, so this is the size one do. Let's check the size one don't. The size one don't has 662 megabytes, and the size one do has 500 megabytes. It's 170 megabytes almost, just because we removed SSH, VIM, and we used the no install recommendations, the no install recommends. Okay, just by not installing stuff by default and by removing what we don't need, we were able to reduce the size by almost 30%. Okay, so this is really helpful and will help you to reduce the size of your images. All right, so let's go forward. How can we do more? Okay, this is exactly the same. How can we got this very same image and improve it? Okay, it will be fast. Okay, and let's check this guy here. I will run again because it will download and so on. You are already used to it, but I will explain as it's being executed. It's not enough just to not install what's being recommended and what you are not install what you are not using. You should also remove the caching of your package manager. I'm not talking about the cache of the container. The cache of the container is good, it's helpful, but once you are running updates and running installations, it will create a cache folder inside your container. So you can use the group unit. See, I'm grouping here and can use the group unit. So once it's done the process of updating and installing and whatever, you will also remove this folder of user for caching. Okay, it's ending here. Let's compare the size of this brand new image. So Docker images. So I have here the size to do, size to don't. Size to don't is 500 megabytes. Just by removing the cache that we are not using, we were able to reduce 15 megabytes beyond. Okay, so, and you know, you look like, oh, but just 15 megabytes. Okay, but remember the beginning. You are not worried about one container, two containers, five containers. You should take care and should set your mind to work with thousands of containers, hundreds of containers, dozens of containers, then it will make a lot of difference for you. Okay, let me check here if we have, okay, this part, but I have some more on the slides just to wrap up this part here. So to reduce image size, so mind unnecessary dependencies. Okay, so you should remove the SSH, VNAM, and whatever you don't need. Use no install recommends. Also, eliminate the package manage cache. Okay, so remove that folder that we use on the package manage use for caching. And also another, I will not show any code about it, but if your framework and the tool, whatever tool that you are using, it's built to make your life easier to reduce the size of your image, also you can use it. And I would suggest to you also, of course, using Quarkus, because Quarkus is made to build Java application subatomic, as the slogan says. So really build Java application smaller, and also GraalVM. If your application is good to use with native images, you can use GraalVM to reduce the size of your application. Depend of the scenario, depend of the case, of course, but those are suggestions for you. Okay, let's talk a little about maintainability. Okay, how can we ease the process of maintaining our application using containers and Java and so on? And the funny part here, guys, is that, let me just switch the folder here. Why this part is important? Because we forget a lot of time that once we create a Dockerfile or whatever file related to containers, we are building code. And this code needs to be maintained. And a lot of times I see developers that don't care too much about maintaining that Dockerfile. And yes, you should build your Dockerfile easier to be maintained. That's why I created this part of the session. Okay, so let's see the first part. Okay, so the first part, we are starting where we ended in the last part. So we'll just create this guy here. Okay, so it's done. How do we look? We have a Dockerfile with a better order. We have a Dockerfile being specific. We have a Dockerfile not installing what we don't need. We have a Dockerfile removing the cache. So let's improve. Let's make it easier to maintain. How can we do it? And this is our new Dockerfile. I call it rely on the official images, because from the beginning of this session so far, I am building my own container image, and that's okay. Sometimes we need. That's why I left it on the session. But a lot of time, and I would say that most of time, most of part of our work, we can just rely on the official image, and that's what I'm doing here. So I can got that very same application that we are using so far, and instead of running update and install and removing cache and whatever, I can just use this official image, in this case OpenJDK. And why I'm telling you right now to use official images? Because when you are relying on the official images, the engineering team that are maintaining the official images, they are following the best practice, they are taking care of the size, they are taking care of patching that image. Whatever I did since the beginning of our session so far to make our image better has been done on the official image, in this case, OpenJDK. Okay, so this will save you a lot of time, a lot of hassles when maintaining this Dockerfile. Okay, it's good, but it's not as best as could be. So let's go to our second part here. Okay, so let me create this new one. Okay, so we are able to do. How can we improve this guy here? And what's been missing so far? I hope that you already figured it out. What I've added here, it's a tag. And it's simple stuff. But for this application especially, it's changing everything, because even the version of the basic image is different. And I see a lot of time developers rely on the latest. Whatever you are using, being a dependency or being a container image, people are not using tags a lot of times. And the problem when you do it is that sometimes your application will break and you don't know why. And I know why, because the maintainers of this Dockerfile, for example, they have changed the latest. They have replaced the latest, and now some feature, some behavior has changed, and your application was not ready to do it. So yes, you should always use the tag. Seems like obvious, but if you go to GitHub and browse some projects, you're going to figure out that a lot of people don't use tags to reference some dependency, or in this case, some Dockerfile, some basic image. Okay, so by doing this, I will know wherever I change on my application, whatever I do, I'm always basing on OpenJDK 8. Okay, so I will not get by surprise, oh, something changed. No, no, no. I'm following this image, and I know that this image is stable, will not be replaced, and so on. Okay, but we can still go beyond. And how can we go beyond? Let me build this guy here just to make, because right now we need to figure out the size. And this is a bonus content for sizing. So we can use something that will make our life easier to maintain application and use it to also reduce the size of our application. So I just built this image as using OpenJDK 8. And now let me just grab this guy here. What I did, I'm not just using OpenJDK 8, but I'm being more specific. I'm using JRE Alpine. Let's check the size. So let me Docker image, maintain string don't. Okay, my don't here .3 is 524 megabytes. and my do here using Alpine is 95 megabytes. Okay, so I jump from 660 megabytes in the beginning of the session. Now I'm just 100 megabytes. Okay, just because I'm using an image that because what's the problem? People it's used to go ahead. Oh, we'll use the default OpenJDK8 and so on. But you figure out that if one image has 100 megabytes and another has 500, 600 megabytes, you really need whatever is inside this 5 to 400 megabytes of difference. Sometimes you don't. In this application, for example, we don't need. So go with Alpine. And if there is another image still smaller, choose that image that is still smaller. Okay, so this is a bonus content that will combine both maintainability and size of your images. Okay, so that's what I'm about to show here. Okay, so to summarize this part, use official images. Okay, so instead of doing a lot of hard work, just go ahead with official images. Also be specific with tags, so don't use OpenJDK, go with the version, and you can even go ahead and use Alpine or whatever you need. Here we have some comparatives. So just the base image on Alpine is 85 megabytes, and on full OpenJDK is 510 megabytes. Okay. All right, folks. This part so far, you can have even more reference if you go to this post on the Docker official site. Okay. And right now, let's go ahead in the end of this presentation, and I will talk a little about resource allocation using Java and containers. And this is the main challenge when using Java with containers, especially in the beginning of Java with containers. Back in 2013, 14, this was really a challenge. So let me just sip some water. Okay, just that I'm able to finish this presentation. Okay, guys, to begin this conversation here, this part of this conversation, we need to realize that before Java 8 build 121, the JVM wasn't aware about a process, this process called containers, that is something that came from a process called C groups. And what is a C group? A control group is a kernel feature on Linux systems that has CPU, memory, disk, network, and all the resources as isolated and accounted and limited for that process. So wherever someone asks you, what is a container? You can say a container is a process. Okay, container is a process. And that process is isolated and has a lot of resources allocated for that process. And this is the main problem when using Java with containers before Java 8 121, because the JVM wasn't aware about this process. So whatever you have, imagine that you have a container with 100 megabytes of memory allocated, and you have a Java application allocating memory, and that Java application wasn't aware about this limitation of this process because he didn't even know that this process exists. So it was always looking to the host, and the host has, I don't know, had 2 gigabytes, for example. So it would keep allocating memory until it will explode and get out of memory and so on. That's one of the main issues that we have with Java using inside containers back in 2013, 14, and before Java 8 121. So if your application is relying on Java 8 121 and before, there is a kind of hack that you can use, was built by the guys from Fabricate. Don't mind of copying this URL. I will let the presentation available to you. But this is a script that will be inside your container and will help the JVM inside your container to get the right limits, the right resources to allocate on your application and you will not have that much of out of memory errors. Okay. On Java 8, 131, and Java 9, the things started to get better. Okay, so now we have some new features, some new flags that can be used, for example, to use parallel threads to limit the CPU usage on a container. Right now, the JVM started to be able to use the C group limit to calculate the memory defaults. And now we are able to use a fraction of the run and not a number. So it's not 200 megabytes, 100 megabytes. No, it's half of the run available, a third of the run available, and so on. On Java 8, 191, and Java 10, some new flags. So initial run percentage, max run percentage, minimal run percentage. So you have more features to calculate the allocation of memory, and also the number of CPUs started to be calculated based on the container allocation by default. So you don't need to turn on any feature in this version. Java 11, Java 11 is the version that we used to say, if you are able to start at least with 11, your life will be so much more easier, okay? Java and containers, okay? So now we have show settings for showing the container metrics. We have this new feature that will improve the calculation and so on. For Java 12 and 13, now you have this tool, the GHSDB, that you can use to debug some JVM that it's dumped. So you can attach it to a Java process running on containers. The container support for flight recorder was improved, and the systemd slice memory also was improved for JVM to limit the allocation of resources based on containers. And on Java 14, we have a new feature, the flight recorder event streaming, that you can expose the data that is being gotten from the flight recorder and expose it in streaming. And also a new tool that in this moment is not maybe built for building containers, but there is a lot of maybe it can be useful for using in containers in the future. So basically here it's an incubator on Java 14 still. It's to build self-container Java applications. It's a packaging tool to create self-container Java applications. All right, so to wrap up here, yes, Java and containers can get along. You can use Java with containers, especially right now that the JVM has improved a lot, but really, really a lot, to make your life easier to work with Java and containers. If you are building Docker files, because today we have some tools that you don't need to build Docker files anymore, but if you are still building Docker files, you can be intentional when you do it. It's better to start with Java 11 and more. And if you really need Java 8, be extra cautious, okay? So be extra careful. And I would like just to finish here this part to let this URL from RedHat developers and also the QR code that you can register for free, and we will send you contents that will help you about Java, containers, microservice, Kubernetes, Linux, and all this kind of content, but really made from developers and for developers, okay? So feel free to register and follow our content. We have a big portal, and whatever event that we are building as Devnexus, master courses, tech talks, and so on, we will send to you the alerts so you can be present as you are here today. So that is for this part. And Mala, if we have any questions, I'm available.
Thank you so much. It was amazing. Thank you so much. So yes, we have lots of questions. To get started, there were a lot of concerns that you were using Java 8. And as you mentioned during the end of your presentation, that yes, people should be conscious about using Java 8. Would you want to add anything else to it?
Well, Java 8, it's the most used Java version, still the most used Java version so far, and we know that's it's a problem that many companies have to migrate and so on. I will not cover this part here, but especially for the support that JVM has on Java 8. Before Java 11, it's a problem, but before Java 8, 121, it's really, really tough. So you will need to use the fabricate script or create another script by yourself. So if you can avoid, please do it.
Yes, makes sense. So there's another question by Jeff, and he's asking, instead of grouping commands, won't a multi-stage build better?
Yes, build stage is great. I wouldn't have time to cover build stage here, but probably we'll create another session because it's worth it. Because build stage is really helpful to use. But if you are just starting your Docker files and building Docker files, the group units will also be helpful.
Right. So there's another concern by Otto, and he mentions why it caches updates also because it changes all the time. And he also mentioned apt-get update might give us different results every time we run it. So why to cache it?
Well, that's why I showed you why you should rely on official image, because that official image is frozen on whatever patches and updates and whatever you have inside your container. But if you really need to use some packaging tool as apt-get and so on, and sometimes you do because can't get rid of using the apt-get. So if you can make a better use of it, and for example, this apt-get that I run it this time today, I'm running here for many days and didn't change. So it's not so common to change it that much. So, but yes, can change, and if that can change, you should make the best use of it.
The next question is by Daniel. He mentioned that we do something about the version of the application. Okay, so he's talking about the changes to the application as they release new versions. So, of course, on the release, it will change. So, the Docker file must also change. I guess yes.
Yeah, well, yes. If you have some reference as I put on my Docker file to the version in the name, and then yes, you need to change. You can always create a jar file without the version. I would not recommend, because you have a lot of risk to replace the last version. Then it will be harder to make a rollback, for example. But yes, you can, if you change the application, if you change the version and the version is the name, yes, you need to change the Docker file.
The next question is by Maximilian, and he's asking whether using the Java runtime images, which are built using Jlink, would that help to decrease the size of the Docker image?
Yes, by far and a lot, because by using Jlink, you can really pick the dependencies. This should be covered on that part on mind the dependencies. So by using Jlink, it will really be able to reduce the size.
Right. So I think we have a similar question by Lakshay, and he mentions, can customizing JRE be a useful solution to reduce the size of image, which you just said yes. Okay, so there's another question, which is, why not build your own Java based image and use it as a base for the rest? That's by you will.
Yes, you can do it, as I showed you, until the part of maintainability, but you will also need you will always need to deal with the changes of the package manager and the orders and so on. And if you are able to base your image on official image, it's easier for you. But if the base image and the official image has something that you don't need or you don't want and will mess up with your application, okay, build your own, but you need to maintain it. Okay.
Right. So, as a more kind of a general question, so there's another question by Shamsul, and he's asking, as a developer, do I need to care about containers?
Yes, you need, and we will need, you will need even more by the course of the next year, because as applications are moving to the cloud, and as applications are are borning on the cloud, and what we call the cloud native application that are made to be born on the cloud, containers will make your life much more easier to escalate, to orchestrate, because imagine that this application here, I can deploy 100 sessions of this application just by doing this, running a Kubernetes command or whatever other orchestration command. If you would like to run 100 sessions of this application using an application server or running a script by hand and so on, your life would be much more harder. So yes, I believe that containers not just some matter of trending and buzzword and so on. It's a matter of tendency that we are seeing on the field, on the industry.
Right. So we don't have any more questions. Thank you so much, Ella. It was an amazing session, and thank you for answering all the questions. Okay, so now that, as I said, there are no more questions, so one question just came in because we have another 2-3 minutes. Let me ask you this. So this is by Shinu, and he's asking, what is the best approach to cache M2 or Gradle cache inside container for faster builds?
Sorry, I missed the middle of the question. To group what? Sorry.
Let me get the question again. What is the best approach to cache? Just a moment. Okay, probably I missed that one. So let me ask the other question. This is by David. Is it recommended to git pull and maven package in the same Docker file?
Yes, you can do it, especially if you would like to keep your build stage always constant and always doing the same stuff. Because as I'm running here on my machine, on my laptop, something can change and will mess with the build. And yes, that build stage that another guy asked before will also help you to, if you can build your application inside the container and have another stage just to build the image. Yes, it's recommended.
So yes, I'm not taking any more questions now. So thank you so much, Elder. Amazing presentation, and it was great to have you present today.
Thank you very much, Mala. Thank you guys that you've been here for this time for 1 hour, listen about Java and containers. And Mala, thank you again. I'm very humbled for the invite, not only by you, but from JetBrains. I really be happy. I mean, really happy here. I'm still nervous here. And thank you very much.
The pleasure is all ours, Elder. And yes, thanks everyone for your questions, for attending the session today. And I wish everyone happy holidays.
Yeah, me too. See you guys.
Bye-bye.
Bye-bye.
Bye-bye.